Class. That's weak sauce. Tree. Tree. Thank you. Thank you. Okay. All right. So, quotient rule. And I'll show you how I'm actually going to change this up. Now, this is the Leibniz notation. It looks kind of weird. We are going to have to use Leibniz when it comes time to do our different implicit differentiation. So we're going to need that one. So it's just, right now, it's just going to be a good reference, but everything else I'm going to use is just going to be regular. So this says when we have two functions being divided, and I cannot reduce it to a single term, f prime times g minus, the only thing that's changing is what I think, I don't know why they do this, but they do it all the time. I just change it to g prime f. I just changed the order because that's the same order that we use in the product rule. Quotient rule, they just put those, they switch those for some reason because they want to. And all that is over g squared. So from yesterday's notes, we identify our f, we identify our g, we do f prime, we take the derivative of f, we take the derivative of g, then put them together. So off to the side on all these problems, I always do this. So f is x squared plus 1, g is 2x minus 3, f prime is going to be 2x, g prime is 2. Yes, no, maybe? So I'm going to go through the order, which is f prime g minus g prime f over g squared. So f prime, that's going to be 2x times g, which is 2x minus 3, minus the product of g prime times f, which is x squared plus 1, all over g squared and this is where those problems actually get a little bit longer. You have to make sure you keep track of your pluses and minuses. And when you are doing the distributing of the 2, you have to distribute the negative also. That's important. Okay, a lot of people are going to make that mistake right there by not distributing the negative because they're zoning out during my conversation here. Yeah, I see you there. Okay. All right, let's do my distribution. I'm going to get, we'll change colors. So you see it, so it's going to be 4x squared minus 6x, distribute here, minus 2x squared minus 2, all over 2x minus 3 squared. So if you notice, I'm just leaving that bottom alone. That's factored and it's squared. So one thing I want to try to do, if I can, is be able to cancel out one of those 2x minus 3's. If I can, I could simplify it at the end, but that's what I'm going to use the top for. So now let's combine like terms. So I'm going to get, it's a positive 2x squared negative 6x and minus 2. Are we okay? Did I make a mistake? Now, if I were to say the F word, because that's how serious I am about this. Factor that. Can I take out any common factors? I can take out 2, right? Okay. So, I'm going to take out a 2, but I'm running out of paper here, so 2. Alright, I need your help transferring this over. So 2x squared minus what? Right? Yeah. Okay, good. Alright, changing up colors again. So I'm going to factor out a 2. And I'm left with x squared minus 3x minus 1. There you go. Can I factor that trinomial? Say no. Because my C term, my last one, is a 1. I can't multiply any numbers together and add them and multiply to get 1, but add together and get negative 3. So that's not going to work out. So that's going to be prime for that one. So I can't factor it further. Now if you notice, that means that this one here could have been the right answer. This one here could have been the right answer. Like I mentioned yesterday, on a multiple choice test, your answer, even though it's correct, might not look like the actual answer that's in the book or one of your choices. So by going through and factoring, that might be one way of actually trying to figure out what an answer could simplify to, or continue to try and reduce it down as much as you can. And I'll mention again, if this is the AP exam, free response, this is correct, and leave it alone. Unless you have to actually keep going, leave your answer as that, because that's all they're going to look for. Did you do your answers correctly? Question? Is that pretty easy? So it's more algebra intensive than some of the others, but it's the kind of only way to do it. All right, the corollary, derivative of the reciprocal of a function. Okay, function is, g is differentiable. Then, if it is differentiable, if you can't take a derivative of it, then the reciprocal, the derivative of the reciprocal, which is 1 over g, it is the derivative of g over, I usually put the negative down here, but it's fine. The negative right here, that's important, and then g squared. So don't forget that negative, because a lot of people do. Whenever you're doing this, you could just use this instead of actually going through and doing all your work on this. Now, can I make this up? I can. By using the quotient rule of this. And I say my original function is this, my f is this, my g is this, and then use the quotient rule, I could eventually get to the same spot right here. So if you ever need to make this formula because you forgot it, then do that. And in this notation, because you're going to see it look like this, you could just jump straight to there. negative g prime over g squared. And I'm going to pick up these power rules tomorrow. So we're going to leave off here, and then power rules going to happen tomorrow. I left these ones on the notes to show you that if you just take the reciprocal, like I did, I showed you, put an F and G, that it works out. You could just do the whole quotient rule instead. Alright, there we go. We'll pick this up tomorrow. Make sure you guys all like, share, and subscribe.